So for this example, I'm going to actually make a table, and it says you need to buy some filing cabinets. You know that cabinet X costs $10 per unit, requires 6 square feet of floor space, and holds 8 cubic feet of files. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. You have been given $140 for this purchase, though you don't have to spend that much. The office has room for no more than 72 square feet of cabinets. How many of which models should you buy in order to maximize? We need to pay attention here because it says they want to maximize the storage volume. And I said we need to pay attention because generally when you set this up, your objective was to find, our objective so far has been to find profits, to maximize profit. Here we're trying to maximize the volume. So notice that for each one of these problems, they give us a price, a square footage, and how many that each one can hold. So when we set this up, the X variable is cabinet X. It's called the X variable cabinet X. I'm going to make a table for this again to help me organize this. So I have cabinet X here. Then I have cabinet Y. It's the other variable, right? And the restraints that are being placed on me is I have a price restraint and I also have a square footage restraint. Let's say footage. And so X costs $10, requires 6 square feet, and Y costs $20 and requires 8 square feet. Now, you're only given for your price, you can have to spend less than $140. You can't spend more than that. And the office only has room for 72 square feet of actual cabinets. So our objective here, Z, we want to maximize the volume, the storage volume. Well, cabinet X holds 8 cubic feet of files. So that'll be 8X plus, and cabinet Y holds 12 cubic feet of files. 12Y. So when I go to set this up, again, I know I need to make some of, here's the actual restraints. I have 10X plus 20Y has to be less than or equal to 140. And then 6X plus 8Y has to be less than or equal to 72. I have to make some of cabinet X, and I have to make some of cabinet Y. Here, the X variable is cabinet X. And here, the Y variable is cabinet Y. Now, when I set this up then, I need to actually set this up to graph these lines. So this first line, I'll graph it in purple, which is 10X plus 20Y has to be less than or equal to 140. I need to get Y by itself. So the first thing I'm going to do is subtract off the 10X. When I do that, I get 20Y is less than or equal to a negative 10X plus 140. I need to get Y by itself, so I'll divide everything by 20. And when I do that, I get Y less than or equal to negative 1/2 X plus 140 divided by 20 is 7. So on this, I'm going to plot 7 down 1 over 2. Do it in purple. Plot 7 down 1 over 2. There's my first line, and I'm below that line, so I'm going to shade this down here. The other line I have, I'll do that one in red. 6X plus 8Y equals 72. less than or equal to 72. Get x by itself. I'm going to subtract off 6x first. So 8y is less than or equal to negative 6x plus 72. I'll divide everything by 8. And I'm left with y less than or equal to negative 6 over 8 is negative 3 over 4 x plus 9. So plus 9 go down 3 over 4. Down 3 over 4. Down 3. There's our intersection. Down 3 over 4. So if you look here, this line is created from here to here. Purple line is out here to here. Your shade, the intersection of those 2 points occurs right. Need to do that again. The intersection of those 2 points occur at this point right here, which is the point 8, 3. Point 8, 3 is where they occur at. There's your first, there's a red line. There's the purple line. And then your other intersections are here at that point, which is 0, 7. And the other intersections down here at this point, which is 12, 0. So if we want to maximize it now, we're going to be looking at the actual shading of the red lines below here. So you're looking at this figure right here. There, you're looking at that figure there. So to maximize this, let's go ahead and calculate those corner points now. And using our profit function, which is, first one I'll do is 0, 7, so that z is equal to 8 times 0 plus 12 times 7. So that means that's 84 cubic square feet, or cubic feet. Next one, 8, 3. Z is equal to 8 times 8 plus 12 times 3. So that is 64 plus 36, which is 100 square feet. And the last one is Z is equal to 8 times 12 plus 12 times 0. That's equal to 96. So we want to maximize it. Here's what we're going to go with. We can maximize it by getting 100 cubic feet. If we go with 8 cabinet X and 3 cabinet Y. And our maximum square footage will be 100 cubic feet. Our maximum volume will be 100 cubic feet.